Hello, 7th graders. It's Mr. LaBeouf, and we are going to begin a journey which will continue into Algebra 1. It is one of the first big topics of high school math, and I'm going to call it linear equations and their graphs. And the problem I have with a topic like this is how to tell the story. Where do I begin? There are many aspects of the story. I'm going to do my best to tell it in a um, in in a story way, in a narrative way, where you learn more and more about the entire situation, and um, everything that you learn hopefully will fit together with what becomes before, and in your mind you create the story for yourself of linear equations and their graphs. I'm going to begin um, with this whiteboard. Down here, I'm going to suggest the importance of Desmos.com. If you find another website or app that you prefer, you can use that, but I have found Desmos.com to be very user-friendly. And many of the things that I'll show you in this introductory video we did before, perhaps with me putting Desmos.com up on the smartboard and looking at the graphs of the linear equations. But I want to sort of start fresh, assume that we don't know anything. And this equation up here, negative 3x plus 2y equals negative 6, is in what's called standard form. And we'll talk more about that in the future. This equation here, y equals 3/2 x minus 3, is in a form that we call slope-intercept form, because this number here, the 3/2, is the slope of the line, which again will be defined and explored a lot in the future. And this negative 3 here is the y-intercept of the line. So that's why this is called slope-intercept. It's actually slope y-intercept, but we usually just say slope-intercept. And maybe some of you might have suspected, or if you take a few seconds, you could convince yourself that these are really the same line. These equations are equivalent. And that's one of the specific skills in this area, is to be able to go from the standard form and put it into this form, or go in the other direction. So maybe you can work with that, see if you can figure it out on your own, why these two equations are equivalent to each other and they are the same line. Well, even if you don't do that for yourself now, Desmos.com is going to tell you that they're the same. This is what I'd like you to do. Throughout all of this presentation of this big topic of linear equations and their graphs, it's going to be a very dull lesson for you if you're not looking at the graphs. So hopefully you have another device, or you can tab on one device and go between my videos or something else that you might be looking at and Desmos.com. Ideally, you should be doing some graphing for yourself as well. You might want to, over the course of these next few weeks when we're exploring this, have some graph paper, a ruler, create an X and Y coordinate plane, and do some graphing for yourself. That's a better way to do things. But even if you don't do that, you should at least think about how you would do it. Imagine doing it yourself and coming up with something that would look like the Desmos.com graph. What I'd like you to do right now, pause the video, go to Desmos.com and type in this equation and take a look at the line. Then on a new line in Desmos.com, type in this equation. You will see that the two lines will be right on top of each other. They really are the same line, which goes along with what I said earlier about them being equivalent. And as I was thinking about how to begin this topic, I decided that the most important thing to understand from the beginning is that the algebra and the geometry are telling the same story. They are two sides of the coin, the same coin. I could give you any number of analogies. I'll often use that one. when you look at that graph, which is a line in Desmos.com, or one that you make yourself, that is a mathematical reality that is the same as the equation. And we'll get into that in a little bit more detail in a moment. We'll look at just the standard form version of this equation, negative 3x plus 2y equals negative 6. And we'll do something that is always of interest to mathematicians. When you have a graph in the x and y coordinate plane, it's always an interesting question. Where, if at all, where, if any, does the graph cross the x-axis? Where does it cross the y-axis? These are just natural questions that you'd want to ask. And when you have an equation like this, it is extremely easy to determine where the line will cross the x-axis and where it will cross the y-axis. Let's start by saying that x will be 0. If you substitute 0 for x here, of course, that first term will go away, and you'll have 2y equals negative 6. I'm not going to write this workout. I think you can follow it mentally, right? Putting a 0 in for x, the equation becomes 2y equals negative 6. And then dividing each side by 2, you would get y equals negative 3. And then we will do the same thing except put a 0 in for y. When you substitute 0 for y here, you get negative 3x equals negative 6. This term will go away when y is 0. Negative 3x equals negative 6. Divide each side by negative 3 and get x equals 2. So what do we have here? Well, we have a pair of x and y that will make a true statement in the equation. When you put a 0 in for x and a negative 3 in for y, you get a true statement. When you put a 2 in for x and a 0 in for y, you get a true statement. The true statement for this one, when x is 0 and y is negative 3, is you happen to get negative 6 equals negative 6. And for this one here, when you put a 2 in for x and a 0 in for y, you happen to get also negative 6 equals negative 6. And that is the number one most important lesson for this area. Because if you look at the graph now, you will see that 0, negative 3. See, because each of these entries of x and y on what we call a t-table, and you don't have to rewrite these because they're in the correct order to begin with. This is called a t-table for obvious reasons, and 0, negative 3 is a point on the line, and 2, comma 0 is a point on the line. And you see, those two combinations of numbers can be seen as two mathematical realities. They are numbers that create a true statement in the equation, and they are points on the line. So I'm going to say two statements that are both extremely important to understand. They go together. Every single combination of x and y that makes a true statement in the equation is a point on the graph of the equation. It's a point on the line. And it works in the other way as well. Every single point on the line, on the graph, is a combination of x and y that will make a true statement in the equation. This is what I meant by two sides of the same coin. That's the most important lesson. Everything else should fall into place once you grasp that. Now, these happen to be considered special points on the line because this point here, 0, negative 3, is, well, you tell me, where is it? It's on the y-axis, right? The point 0, negative 3 is on the y-axis. That point is called the Y-intercept. The word intercept, just like in football and interception, the defensive player is coming together with the ball. And the x and y intercepts are where the line comes together with the axis, the x or y axis. The word intercept is very similar to intersect. They're pretty much the same thing. This point here, 2 comma 0, look at where it is. It's on the x-axis. So this point here, 2 comma 0, is called the x-intercept. Now, for this equation, there are an infinite number of combinations of x and y that will make a true statement. It won't be any old x and y that you just happen to choose. They have to go together. But there are an infinite number of them. An infinite number of combinations of x and y that make a true statement in that equation. And every one of those combinations of x and y that makes a true statement is a point on the graph of this equation. It's a point on the line, just like with these two. Let's do a couple of more. Let's try x equaling 1, and then we'll try x equaling -1. Now, back here, I tried y is 0 because I had a specific goal of getting the two intercepts. First, I chose x equals 0, then I chose y equals 0. But typically, we're going to start with x. And when we use the other form of the equation, which I showed you at the beginning, we're always going to start with an x there. This whole area of what are called functions, that's something we'll talk about a little bit later. A function is like an in and out box that you're introduced to when you're very young. And the x's are generally thought of as the numbers that go in, and then the y is what comes out of the in and out box, otherwise known as a function when we get into the higher levels of math. And so I'm going to choose 1 for x, and then I'll choose -1 for x. Now, one of the things you have to be ready for is that things don't always come out to be nice integers. They did here when we chose the zeros, but when we choose a 1 for x here, put a 1 in for x, this time I am going to rewrite the original equation with a 1 substituted for x. And I'll go through the steps. This marker is kind of failing me a little bit here, but I think it's legible enough. So all I did was put a 1 in for the x, got this. -3 times 1 is -3, of course. So now we have -3 plus 2y equals -6. And of course, math is incremental. You're going to be called upon to use your equation solving skills in this area. Anything you learn in math, you're probably going to use it frequently in the future. Now we're going to add 3 to each side and get 2y equals -3. I didn't show the +3 here and +3 here, but there's the next step, right? 2y equals -3. And the final step is to divide each side by 2. Dividing by 2 here will isolate the y. Dividing by 2 over here gives us y equals -3 halves. -3 halves. So what we have here is, I'll use the horizontal form of the fraction here. When x is 1, y is -3 halves. This is another one of the infinite combinations of x and y that makes a true statement. When you put in a 1 for x and a -3 halves for y, the left side will be -6. You'll get -6 equals -6, a true statement. And also notice, go to Desmos now, and notice that one of the points on the line is 1 comma -1.5. It'll say in Desmos 1 comma -1.5, of course. Desmos uses decimals. You should be able to slide the cursor over the line, and it'll then display the point for you. You should be able to find that point. Now we'll do the same thing for x equals -1. Erase some of this work here. Now I'm just going to sneak a minus sign in there. See, before that was a 1. Now I'm putting a -1 in for x. This time -3 times -1 is +3. We get 3 plus 2y equals -6. Very similar to before. This time, though, we're going to subtract 3 from each side and get 2y equals -9. Right? I substituted -1 for x into the original equation and solved for y. Dividing each side by 2, we get y equals negative 9/2, negative 4.5. Y equals negative 9/2. I'll put that in on the t-table now, just like before. I'll write it as a horizontal fraction. I didn't leave myself enough room to write it vertically. So when x is negative 1, the y is negative 9/2 or negative 4.5. This is another combination of x and y that makes a true statement in the original equation. And there are an infinite number of them. And this is another point on the line. You should also confirm for yourself that one of the points on the line is negative 1, comma, negative 4.5. Desmos will tell you. So this is the beginning of a wonderful journey into a big topic of high school math. This is one of the first, if not the first, big topic of high school math in my mind that is extremely interesting. I suppose high school math begins with rational number operations, adding, subtracting, multiplying, dividing with rational numbers, including integers, but also fractions and negative fractions, that big group of what we call rational numbers. And of course, we had to do some of those rational number operations and the solving of equations that we learn how to do before we get to this topic. But then we put it to use, and it's really interesting. It's not just a dry, isolated equation where we get an answer and the teacher says that's right. This time, when we're using our algebra skills, we're able to see on the graph that what we did algebraically is on the graph as points on the line. So this is the beauty of it. Math is getting, I think, more interesting and rewarding at this point. So enjoy the topic going forward. We're going to call it quits for now. But again, let me emphasize that big picture lesson that we get combinations of x and y that make a true statement in the equation. There are an infinite number of them. And every one of those is a point on the line, which is the graph of the linear equation. And of course, any line has an infinite number of points. Infinite number of combinations of x and y solving the equation, infinite number of points on the line. So enjoy this big topic. We will learn many, many awesome things about it. Linear equations and their graphs. Take care for now.